Intramolecular versus intermolecular forces. Have you ever wondered why diamond is one of the hardest substances on Earth, while ice melts easily in your hand? Or why water boils at 100 degrees Celsius, but oxygen remains a gas at room temperature? The secret behind these amazing properties lies in two important concepts of chemistry: intramolecular forces and intermolecular forces. Although these names sound similar, they are completely different. Understanding their difference is essential for MDCAT, FSC, NEET, and many other chemistry exams. Let's begin with intramolecular forces. The word intra means inside. So, intramolecular forces are the forces of attraction that exist inside a molecule. They hold atoms together and form chemical bonds. Without these forces, molecules simply could not exist. Intramolecular forces are extremely strong because they involve the sharing or transfer of electrons between atoms. These forces determine the chemical identity, composition, stability, and structure of a substance. There are three major types of intramolecular forces. First is the covalent bond, where atoms share electrons. Water, methane, carbon dioxide, and glucose are all held together by covalent bonds. Second is the ionic bond, formed when one atom transfers electrons to another. Sodium chloride, or common table salt, is a classic example. Third is the metallic bond, which holds metal atoms together through a sea of delocalized electrons. This is why metals are good conductors of heat and electricity. Since intramolecular forces are very strong, breaking them requires a large amount of energy. More importantly, breaking these forces changes the chemical identity of the substance. In other words, it causes a chemical change. Now let's move to intermolecular forces. The word inter means between. Therefore, intermolecular forces are the forces of attraction that exist between different molecules. They do not hold atoms together. Instead, they keep molecules close to one another. These forces are much weaker than intramolecular forces, but they are incredibly important because they control the physical properties of substances. For example, intermolecular forces determine whether a substance exists as a solid, liquid, or gas. They also affect melting point, boiling point, viscosity, evaporation rate, surface tension, and solubility. There are four important types of intermolecular forces. The first is London dispersion forces, also called van der Waals forces. These are the weakest intermolecular forces and are present in every molecule, whether it is polar or nonpolar. The second type is dipole-dipole forces, which occur between polar molecules because their positive and negative ends attract each other. The third is hydrogen bonding, the strongest intermolecular force. It occurs only when hydrogen is directly bonded to nitrogen, oxygen, or fluorine. Water is the most famous example of hydrogen bonding. The fourth type is ion dipole forces, which occur between ions and polar molecules. These forces explain why salts like sodium chloride dissolve so well in water. Unlike intramolecular forces, intermolecular forces require much less energy to overcome. Breaking them does not change the chemical identity of a substance. Instead, it only changes its physical state. For example, when ice melts into water or water boils into steam, only intermolecular forces are weakened. The water molecules themselves remain unchanged. Now let's compare both types of forces. Intramolecular forces act inside a molecule, while intermolecular forces act between molecules. Intramolecular forces are very strong, whereas intermolecular forces are relatively weak. Breaking intramolecular forces causes a chemical change, while breaking intermolecular forces causes only a physical change. Intramolecular forces determine the chemical properties of a substance, whereas intermolecular forces determine its physical properties, such as melting point, boiling point, viscosity, and solubility. Here's an easy memory trick. Remember, intra means inside, inter means between. So, intramolecular forces act inside molecules, while intermolecular forces act between molecules. Many students think hydrogen bonding is stronger than covalent bonds. This is incorrect. Hydrogen bonding is the strongest intermolecular force, but it is still much weaker than covalent, ionic, and metallic bonds, which are intramolecular forces. So always remember this golden rule. Intramolecular forces build molecules. Intermolecular forces hold molecules together. If you found this video helpful, don't forget to like, share, and subscribe to Easy Chemistry, where complex chemistry becomes simple and easy to understand. Thanks for watching, And I'll see you in the next video.